Okay, so we're talking about making great VR and eliminating motion sickness, because I feel personally that's one of the biggest issues in the current crop of VR devices. VR has been around for 30 some odd years. We're talking about flight simulator stuff too, which there's some similarity there. But just in the last 2 years with Valve and Oculus and Sony getting into it, you've seen a big advancement in the technology and the software side and the hardware side. A little bit about myself. I'm an artist and game designer at Uber Entertainment here in Bellevue. We're 2 blocks away. Been making games for about 18 years. Those are some of our games. I switched over to VR development about 10 months ago because I went over to Valve, which is also down the street, about 1.5 years ago. This is what they called I think they called it the Valve Room. It was their VR research room where essentially you can walk around, wear a headset, and it was a magical experience. It was the most compelling VR that I've seen up to date, and really felt like it was being transported to another place. It's a combination of high frame rate, low persistence, low latency, full tracking with head, and a high resolution display, and really wide field of view. The ability to walk around the space was interesting too, because I've never had that in VR. We can essentially, this is a 15 feet by 15 foot space, and you can walk around the whole space wearing a headset. And it didn't matter that some of the demos, one of the initial demos was just like a cube. You walk over it, and there's this one moment where you're supposed to walk over the edge of the cube and walk away, and I could not do it. It just felt like I was actually on a ledge, and it was amazing. So the art, low poly art or high res textures, none of that really matters as long as the frame rate's there and all the presence is there. I was completely bought in at that time, and I was trying to figure out a way to work on VR. And then I want to talk about the current VR platforms. So on the top left is the Vive from HTC and Valve. The first experience I had with VR development is the top middle, which is the Gear VR. And those faces everyone's making, that's what you do the first time you put on a headset. VR face. All right, so we got our dev kit, I don't know, 10 months ago or so from Samsung and Oculus. The interesting thing about the Gear VR, it's a mobile VR experience. So in that device is essentially a S6 phone, Samsung phone. You strap it onto the headset, and that's about it. Like, everything's on the phone. It's completely wireless, portable. Resolution's pretty good on it too. The only thing you're lacking for mobility is positional tracking, so you can't move your head back and forth. It's just stuck to your face, but you can orient around and do cool things with that. There's also, on the right side of it, there's a touchpad. So one of the first games that we designed for it was a point or look and click adventure game. So you look around, and click, and move the character around. So it runs 60 frames a second, which is pretty good, but some people have a hard time with that. Some of the other devices run at 75. The DK2 runs at 75, and then the Vive and the new Oculus kit runs at 90 frames a second, which is really 90. A lot of people feel like 90 frames a second is where real VR immersion starts. I didn't include anything about Google Cardboard. I had a really bad experience. I don't know if anyone's tried Google Cardboard. I tried it once, and I was like, okay, I can't take this. So the difference between this and Cardboard is Cardboard uses your phone and the built-in accelerometers on it and the gyros, where on the Gear, there's custom accelerometer and gyros on the headset. That's why it's also the price difference. I think the headset is like $200 plus the phone. But I've been walking around with the headset. I didn't bring it here today, but at GDCs, it's the easiest way to do a VR demo. I mean, you just take it out of your bag and plop on someone's head or on a plane. So there's some trade-offs to it, but it's a great device for portability. I did get a chance to check out Sony Morpheus at this year's GDC. I think they're calling it 2.0 right now, and that was an amazing experience. So this will be really the only console VR experience that'll be out anytime soon, as far as I know, unless Microsoft announced something else. But so this will ship next year. The Gear VR is shipping, I believe. There's a developer edition, so if you want a developer, you can buy one now. But I believe it's shipping another year. And Sony ships their stuff early next year. So this runs at 60 frames a second and also runs at 120. And you can make a game at 60 and have it frame double essentially to 120, which is what we're doing with some of our games and tests we've been messing around with. It runs on a PS4, has positional tracking. You can control it with a PS4 controller, which tracks in VR, or the Move controllers, which gives you full motion controls, essentially, and they track with your hand, essentially virtual hands. Again, the GDC demo is really amazing on those. So most people that are in VR right now, they're probably day-to-day, is going to be the Oculus Dev Kit, the DK2. On the top left is it's hard to see, but what the final hardware is going to look like when they ship it. That's going to be early next year, I believe. So the DK2 is a high-end PC experience. There's a headset, the little camera to the bottom left, that's the tracker, so you can move your head around and get closer to things. We prototype with motion controls on the top right. That's not by Oculus, it's from Sixth Sense. It's called the Razer Hydra, which I don't think they sell anymore, but you can get them off of eBay. But it's the closest thing to motion controls you can buy right now, unless you have a Vive dev kit, which aren't out yet, in the wild. Not too many of them. It also works with an Xbox controller or a mouse and keyboard. But that's what I use day to day for. We use Unity and a DK2 for development. I just came back from a game jam in Austin this past weekend that was hosted by Valve and Alchemy Labs, and it was a 2-day jam. We had to create a game to run on the Vive headset. It's a fun experience. We started a week early, but I want to spend my time just getting the game working. If I have time at the end, I'll see if I can show it. But so the biggest difference between the Vive and everything else is, if you see on the bottom right of the screen there, those two objects that are going to be attached to a wall, it's called a lighthouse setup. And they're essentially two boxes that just paint the room with lasers. And anything within that volume that can receive it, like the headset and the controllers, it tracks it. So you can walk around the space as long as you're within the tracking volume, up to 15 feet, and immerse yourself. It's the most immersive experience I've had because, again, you can walk around, pick stuff up. And the cool thing about tracking the controllers is once you put your headset on, you obviously can't see where the controllers are, but they show up in VR because they're tracked. So let's talk about motion sickness. People also call it VR sickness, simulator sickness. Why does it happen? We don't know the full physiology of it, but a lot of it to do with the mismatch of what your eyes are seeing and sending to your brain versus what your ear and your body is sending to your brain. So if there's a mismatch there, and people will get sick and feel bad and won't want to play your games anymore, and over VR. So it also could be caused by bad calibration of the hardware or distortion correction, but a lot of that's getting fixed now with the Steam VR SDK and Oculus SDK, so that's not something the user or the developer has to worry about so much. Other specific things can cause motion sickness or changing the head orientation without the user input. It feels, if you rotate the head in VR, it feels like someone grabs you and does this, and it does not feel good because you don't expect it. So we typically don't like to rotate the head. You want to, the player is the head. So you want to also make sure you don't take it over. Changing the field of view is really bad too. It feels, yeah, don't do it. Or ignoring or overriding head movement. So if there's load screens and things like that, you don't ever want to not have the player to be able to move their head around. If it looks like there's no response, it just throws everything off. Your brain freaks out. So some of the ways to fix this, two major things are low latency and consistent frame rate. So don't ever drop frames. You can't ever drop frames because if you drop a frame, you will see a hitch. I mean, there are some software solutions that'll help sort of predict that, but generally when you're developing, just keep your frame rate stable. So depending on the hardware, obviously. So for Vive, it's 90 frames a second times 2 stereo, and 75 for DK2, and 60 for Gear VR, and so on. There's also other issues. So you can have a really high frame rate, as we have done some of our tests, but then the time it takes for your head movement to reach the screen and render, that's latency issues. And both the Vive, the Morpheus, and all the other kits have pretty low latency in regards to that, so that shouldn't be too much of an issue. There's a bunch of ways to control frame rate. I mean, we use Unity. I don't know if any Unity users. I'm sure there's a lot. Yes, everybody. There's, just profile in the editor or profile with the build. Our biggest things when I was doing the Gear VR demo, which is in the Oculus store right now, is the number of draw calls you can have. So in Gear VR, it was like 100 in any visible camera. And on DK2, I'm using like 700 or more. So keep your draw calls low, keep your lighting, any per pixel lighting, that also blows stuff up. Any complex shader blows stuff up. So you got to start really simple, keep a high frame rate, and just add till you drop frames, and then cut back. You can also bake in lighting too in Unity, which works out pretty well. And full screen effects don't work so well. So a lot of the fake like screen space ambient occlusion just doesn't work in full stereo. Bloom still works. I love Bloom. I try not to overuse it, but again, if you have the frame rate, if you have the performance, you can use it. Like I mentioned earlier, so don't optimize. Like regular game development, we end up just throwing stuff in and optimize it before we ship. Start, optimize, start high, and just maintain it. Because when you want to get people testing the game, and it's just going to suck. You're going to get really bad data if the frame rate is not there. So just keep the frame rate. I try to do it, but sometimes, like next week I'm going to spend a lot of time optimizing because we end up seeing some issues with our current demo. There are a lot of great resources from Oculus, from Valve, from Unity about how to develop for, actually Unreal stuff too. They just added support for SteamVR recently. The other thing is very important. From the point of when you demoing your game or app, as soon as they put the headset on to the full session, till that person takes a headset off, make sure that you maintain VR immersion. So any loading screens, any loading, anything, any logos or end sequences, make sure that they can move their head around and there's a response that happens. The display should always respond while they're in VR. So locomotion, that's a big issue. If you're sitting, how do you move a character around? How do you move from level to level? So in the Vive, you can actually walk around in space. So one of the things that we're experimenting with is cutting the camera between regions. I'll show you a little sample of that, but really, in general, for locomotion, let the player know that there's going to be locomotion. So, for example, they walk into an elevator, you hit a button, you hear the sound of the elevator starting up, and it goes, right? Like they know that if I hit this button, the elevator's going to go up and down. So sound feedback, motion, they expect it. And provide any audio, video feedback you can. Minimize the duration and the frequency of a locomotion in VR. You don't want to do it a lot. And again, it's going to vary from player to player. So this applies to any change of motion, not just forward motion. So any slowing down, speeding up, rotating around, it could feel bad if you do it too often. Constant movement works a lot better than easing in, easing out. So we do have an elevator sequence in one of our games where just hit it, it just goes, and it feels all right. Adding a frame of reference. So I don't know if you guys seen like space simulators like Elite, or that's one of the best VR demos out there right now. And you are flying 360 degrees. Like you're doing barrel rolls, going upside down, and it works well because you have a frame of reference. You have a cockpit that's with you the whole time. So having a frame of reference in your periphery, that seems to work really well for any motion. All right, here's a sample of a game that we're currently working on. Oh, can't hear sound, but it's okay. I'll go more into the game a couple of slides, but I was running at 30 frame video, so that's why it looks so choppy. But when you see it at 60, the other thing you'll notice when you're looking at video footage of people using VR, we don't realize how much we move our heads around. So watching video makes me sick sometimes too. All right, so talking about cameras, and I know there's been a trend for a lot of traditional games to start to use more cinematic techniques and take control of the camera, move the camera around, change FOVs, things like that, and a lot of that stuff just don't work. Because essentially, you want to treat VR like theater, not a film. So your head is someone's eyes, not a camera. So don't want to really do too many camera tricks. That's going to interfere. It's going to make you feel bad. Excuse me. So how do we get around a space? So instead of moving the camera to a space, we end up doing blinks. You do a quick couple frame blink, you go to black and out, and that works real well. When you see it on video, you notice the blink. When you actually have a VR headset on, I don't know if you guys consciously notice that you blink normally, but it feels like that. You probably will now that I talked about it. So you really don't animate the camera anyway, because you're essentially grabbing someone's head and moving it around, and it doesn't feel good. Screen shake is also not a good idea in VR, but I have seen it done well. As long as there's a frame of reference, like in a cockpit, as long as it feels like, you ever been on an airplane with turbulence? It's like the plane moves. So as long as the world moves and not your head, it seems okay, but again, experiment with that. And lateral motion seems to work better too. All right. So this, the game we're working on right now, it's a third-person look-and-click adventure game. You essentially control an avatar. So the camera is, we scale you up. So scale is really interesting in VR. We scale you up 10 times bigger than you are. So you're essentially a giant, 60 feet tall, looking down on space. It's something that doesn't come across in video. I mean, you really get a sense of scale. So everything feels like a miniature. And I've done demos where scale something 1,000 times bigger, and it feels really, really cool. So in this game, in third person, you're controlling avatar around, and there's moments where you go to first person, and then we scale you back down to regular player human height. And between cameras, we blink. So we go to black and out. And I did say don't use cinematic techniques, but one thing we found out works for this kind of game where you're moving around a space. If you keep your blinks between 180 degrees, 180-degree rule in film, it works really well. So if I'm looking at a space here and I blink to a camera at a different location, as long as it's within 180 degrees, there's a point of reference for the player, that works really well. So there we go. So there's a blink there. We go into first person and we change scale. And we go back out. There's a camera cut there. And back to first person. So the game just goes back and forth between third and first with moments. So the other thing we've discovered is the transition. If the player expects it to transition, then it works a lot better. So if you walk into a doorway, walk into a room, walk up near a ladder, walk up to a puzzle, and you do a transition there, that works a lot better than doing it in the middle of a floor or something. The other thing that's found out the hard way is high-frequent textures cause eye strain. So the longer you're in a session, the more that it will bother you. So you don't have depth of field in VR. We don't have eye tracking yet, but just simple Unity fog does the trick. Just blend stuff down and just try it. And generally, just keep low frequency textures and big broad shapes and colors. Seems to work better. The other thing, the 10 months I've been working in VR, you get used to bad VR really quickly. So I'm not a good test case for a lot of things anymore. So you want to make sure, that's again another reason to keep your frame rate high, because you want to get new players in and see how they feel. Everyone's going to feel differently about it, but generally there are things that work, which is like low latency, high frame rate. And people's sensitivity differ. It may differ on different days. Like some days, like certain motions will bother me, other ways it doesn't. So we just don't know enough about it right now. And even after 10 months, I'm still very sensitive. Like I did a demo in Austin that had a camera zoom, and it just like wrecked me for the rest of the day. That's bad if you're working in VR all the time. The other interesting thing that works well is representing the virtual controls in VR. So like I said, for the Vive, you put your headset on, you see the controls, and you map it to the button setup of the actual physical controls. And when you pick it up, it feels really good because your hands are touching the actual controls. The Gear VR has a touchpad, and Morpheus has their own thing too. So that anytime you can represent the virtual controls in VR, that's great. Especially since you can't find, I end up doing this a lot, where putting the headset off, trying to find my mouse, and putting it back on. But so mapping virtual controls works well. It's really fun right now. Right now is a really good time to jump into VR. There's nothing's set in stone. There's a lot of experimentation going on. I think there's 2 game jams, the Gear VR game jam and a Vive game jam that happened all last week. And there's been a lot of change over the last 2 years. It's a good time to experiment and try it out. Again, it's been really fun. But of all the stuff that we've learned, we still don't know anything really. Like we've barely scratched the surface. So all these rules that I'm making up as I go and learn from other people, I've found some of them are, yeah, that might work, might not work. So you have to really just try a lot of the demos out there and experiment on your own and see what works. And that's about it. Thank you.
We have 5 minutes, so we can ask some questions. I'll bring the microphone over, or you can project and we can paraphrase the question either way.
Hey, I work in the esports field and have had the opportunity to try a couple, like the Oculus and the Vive.
Yeah.
It seems like VR esports games are probably a ways off, but it also seems like it'd be really cool to be able to spectate esports using a VR system and having the camera move around.
Yeah.
And the example you showed with a third-person camera,
right.
How does that work out when someone's in that third-person mode but actually able to move the camera themselves?
Well, moving the camera is moving your head. So.
Well. I mean, almost like playing, I did play Team Fortress with the DK2,
right.
Where you have a camera control
right.
instead of just your head so that you can change your axis that you're looking down
Yeah, so
on.
the sort of FPS model, like TF2 makes a lot of people sick.
Yeah.
Like Valve doesn't do that kind of stuff anymore.
Yeah.
That was like a first experiment. So a lot of the tendencies for first-time VR devs is to, I want to make GTA in VR. Like it just doesn't work. So there's no good solution for it. So cutting cameras, like, if you talked about a sport analogy, like, if you're watching a football game, cutting cameras and having control over which cameras that you can see from, that seems to work pretty well. But generally, like moving the player around while they're sitting, it's just going to mess you up. And you're probably less sensitive to that when you play TF2. Yeah, when I tried TF2, it wrecked me. So you got to be mindful about that, yeah. Anything else?
So you mentioned about the first-time experience, especially when you're beta testing a sort of game. If it's not quite perfect, then people can have a really sort of sucky experience. Sort of when do you have any idea about when is the right threshold out? It's baked enough that we can get some feedback in it, but it's not early enough that we're going to damage their experience for it.
So the thing about VR is you could just have white boxes, and as long as there's a high frame rate and a low latency, and you're not trying to move the player around, it works. So I would test early on. Again, just you got to maintain your frame rate and not try to have no hitches. So that's really the basic rules of it so far, as what we know today, which might change in a year, as the hardware gets better too.
Okay, well we finished. Are you going to stay here for the rest of the day? If people ask
I'll be
questions?
around. Yeah.
Okay, awesome. Yeah. Well, thank you very much for coming in. That's
no
great.
problem.
We're starting in 5 minutes.